Chi-square test has a wide range of applications. Other than comparing multiple population proportions or testing to see whether observations follow certain distributions as we have done in previous presentation, we can also use chi-square test to perform a test of independence. This test of independence is used to verify whether two kinds of classifications have any association or relationship or not. If they have certain association, we would say they are dependent or not independent. If they have no relationship, we would say they are independent. In this presentation, we would discuss how chi-square test can be used to perform this test of independence. Consider the scenario that you are the marketing director at Coca-Cola. Recently, Coca-Cola has developed some new cola flavors. And as the marketing director, you would like to test several international markets to see whether there is any kind of association or relationship between the nationality and the flavor preference. To do this, you have carried out a study. Out of the 115 Americans recruited for this study, 72 preferred cola A, and 8 preferred B, 12 C, 23 D. You also recruited 85 Canadians and 50 Mexicans. The results are presented in this table. It is clear that we can classify the subjects according to either their nationalities or their cola preference. The null statement for the test of independence would be the two classifications, namely the nationality and cola preference, is independent, and the alternative would be that they are dependent. Again, this is in accord with what we have described before. The null is the statement for no effect, and alternative is the statement for there is an effect. The test of independence is fairly similar to chi-square test for comparing multiple population proportions. We would have to set up a table of expected frequencies. The expected frequency for each cell is the corresponding row total times corresponding column total divided by the grand total. Instead of having two tables, you could also set up only one table with two different sets of labeling, meaning that you would have both observed frequency and expected frequency in each cell. To compute the test statistic, what we need to do is use FO minus FE for each cell, and then we're going to square that difference, and then we're going to divide it by FE. Afterwards, we're going to sum up all of these entries. I hope that you are convinced chi-square statistic is a measure of a similarity or difference between the observed frequencies and the expected frequencies. The degrees of freedom for test of independence is slightly different from the degrees of freedom we have discussed before, because we have two different sets of classifications this time. The degrees of freedom is equal to number of populations in the first classification minus 1 times the number of populations in the second classification minus 1. P-value would be the upper-tailed probability of a chi-square test statistic of 42.75 with 5 degrees of freedom. From the chi-square table, this would be almost 0. We have sufficient amount of evidence to reject the null. We conclude nationality and cola preference are not independent. The following two examples are other similar examples on test of independence. I will not go over the details here. The keywords for test of independence would be dependent, independent, dependence, independence, depends on, associated with, and association.